Hello friends, welcome to Shiksharthi. In this session, we shall be discussing odd functions. So let's start. Now, as always, there is a prerequisite for this session, and the prerequisite for this session is that you should have done all the sessions that we had done or we have done till date on functions, which gives you a broader perspective to understand odd functions. Okay. Now, when we are discussing odd functions, we are assuming here that the function that we are taking here would be g of x. Now, g is an operator on x. So, point number one, if g of minus x, okay. So now when we are saying if g of minus x is equal to minus times of g of plus x, or if g of minus x plus g of plus x gives a 0, then gx is an odd function. Okay, and then the difference that we are trying to bring forth here is we are talking about non-graphical presentation. We are talking about the non-graph interpretation. So the definition to the odd functions that we are trying to bring forth is a non-graphical definition. We'll be able to understand this better with the help of an example. So we are taking an example here now. For example, okay, let's take gx equal to 1 by x. So if you recall, we have always been talking about the importance of the domain and range. And here you are comparing their ranges. So what we are trying to say here is if g of minus x, which is you're operating on the negative domain of the function, when you operate on the negative domain of the function, if the negative operation, if the operation on the negative domain of the function is equal to minus times of the operation on the positive domain of the function, in that case, the function behaves like an odd function. So before we go ahead, as discussed in the earlier sessions also, let us first specify the domain of this function and thereafter perform any mathematical operation. So we have specified the domain of this function gx, which incidentally here is 1 by x, and thereafter what we are trying to calculate is we are trying to get the value of g of minus x, which is nothing but 1 divided by minus x, which eventually can be written as minus of 1 by x. Analogously, we are calculating the value of g of plus x, which will be 1 divided by plus x, which eventually results in plus of 1 by x. Now when we add both of them, so I'm assuming that this is, let's say this is equation 1, this is equation 2, and then when I add both of them, so the left hand side I'm getting what? I'm getting g of minus x added to g of plus x, which gives me a 0 in the domain of the function. Since this happens, which is why we will say that this function is an odd function. So we were able to prove this with the help of non-graphical tools. Now, the next thing that we are going to bring forth here is we are going to discuss the graphical aspect. Now, when we are talking about the graphical aspect, what will we do? We will plot the entire non-graphical piece of information on the graph. Okay, so we know that this is okay. Instead of calling it as fx, so we know that now this is the positive side of gx, this is the negative side of gx, positive side of x-axis, negative side of x-axis. We know this, and once we know this, let us try and understand that if we would have taken now when we are plotting this piece of information, which is the non-graphical piece of information graphically, let us assume a point. So this is a point that I am assuming, and here I am treating the function as a point function. Okay, so now in that case, this would be plus times of g of plus x. If the same point is taken symmetric about the y axis, it would go on the left hand side, but as of now I am taking the same point symmetric about x axis. Now, if I would have taken the same point symmetric about y-axis, I would have taken it as discussed earlier on the left-hand side, which will be plus times of g of minus x. And thereafter, I could have taken the symmetricity of the same point about the x-axis, which is this, which will be minus times of g of minus x. And then this is the point to understand, these are equidistant. So what is the resulting figure? The resulting figure is a quadrilateral, no doubt, which has its vertex angles as 90 degrees. So in that case, the resulting figure here would be either a square or a rectangle. Okay, now let me name the quadrants here. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. And this is the neutral point, so 0. So wherever the axes they intersect with each other, that is known as the origin, and the coordinates of the origin are 0, 0. Okay, going forward, now we know that if g of minus x, which is this, is minus times of g of plus x, that means what are we trying to indicate? We are trying to say that whatever is there in the second quadrant, if the same thing is there in the fourth quadrant or vice versa, that means, we are talking about symmetricity. So this is a sign, so double-sided arrow, which in any case is the representative form of a line, is the sign for symmetricity. So if the graph, whichever graph you have of a function in the second quadrant, and the same graph you are able to see in the fourth quadrant as well, it is symmetric in the fourth quadrant, or we say whatever we have in the first quadrant and the same graph is symmetric in the third quadrant, that means the function is an odd function. and we call this as symmetricity about origin. So symmetric about origin. So if there is a function which is symmetric about origin, symmetricity about origin is, do not, on a lighter note, please, when you see the axes, you see it in the form of a additive sign, plus sign, but see it diagonally. So when you are viewing the axis diagonally, you will see it from the perspective of a multiplication sign. The multiplication sign means whatever I have in this quadrant, which is the first quadrant, if there is a symmetricity in the third quadrant, that means the function is an odd function, and vice versa. So are all odd functions symmetric about origin? Yes. Any function which is symmetric about origin, is it an odd function? Of course. So this is a very, very important conclusion, and I hope you will be able to take this learning to the next level.